Welcome back to another video on AA learning. Today we're going to be sticking with the math concept, and this time of the algebra realm, and that's going to be of long division with polynomials. So before we actually start examples of long divisions with polynomials, I'm going to go over some prerequisite stuff that you guys should know. And first, that's going to be what is a polynomial. Okay, so polynomials, they're basically functions with multiple terms, variables, coefficients, constants, stuff like that. So let's try an example of a polynomial. So that would be x squared plus 8x plus 3. So this is like a traditional polynomial that you guys will probably see, and this just like this part right here, that would be a constant, and that's an example of what functions are with polynomials are. And then they also have variables like this x value right here, and they also have like coefficients, like this 8 is tying with the x, and there's like 1 with the x squared. So that's what polynomials are. They just basically have multiple terms, which include variables, I'm just gonna write vars for short, coefficients, and constants. Yeah, so that's just like a quick overview of what polynomials are. But yeah, let's also review the quickly what division, like the division terms. So obviously you guys know when dividing, you simply can set up like this, and then 6 times what gets you 18, and that's 3. So your answer was 3 when dividing, right? But you guys also need to be familiar when doing polynomial long division of like the terms. So this right here, this 18 that we initially put, that's called the dividend. Dividend. Okay, that's the number inside when you're dividing. And this right here, the 6, that would be the divisor. Divisor. And this 3 right here, that's your quotient. And usually, like, this question doesn't, and sometimes, not usually, sometimes there's like a remainder, but in this case, the remainder is 0. So we do just write r is equal to 0. This remainder part can be really important when we're doing polynomial long division, so that's why I'm including it here. I know obviously when you're doing division like this, you wouldn't indicate there's a remainder unless asked, but usually in polynomial long division, if you have a remainder, you should definitely indicate it. So, oh yeah, and this, I'm just going to write 18 over 6 just like this. The terms still stay the same. So this is still the dividend, and this is still a divisor. Okay, let's get into some examples now of polynomial long division. I'm just going to label this example 1. Example 1. Okay, and the question is 2x cubed plus 3x squared minus 2x minus 3 divided by x plus 1. Okay, that's our first question. So usually when you're doing polynomial long division, you write it in this form, which I'm gonna write now. So you have x plus, you have the denominator on that side, just like how you have in normal division, and then you have the numerator in the inside. So it'd be 2x cubed plus 3x squared minus 2x minus 3. Okay, now what our goal is to divide this term. So what we have to do is look at the lead number. We know the lead number is 2x cubed. So x times what will give us this 2x cubed. We have to use the values here to get 2x cubed. So what I like to do on the side is just, okay, so we have x plus 1. What other term do we have to multiply to get us 2x cubed? Well, if we use 2x squared, we can just double check that by multiplying these terms right here. So we gotta distribute those terms right here. So that 2x squared becomes 2x cubed, and that's what we want, right? That we got. And we still have this plus 2x squared left over. So again, remember when dividing, you're subtracting. So what would happen here is you would write this 2x squared, because that's what you're multiplying right here. Remember, just like our basic example, we had 18 and 18 divided by 6, and we know that's 3. So 6 times 3 would get us 18. So that's 2x squared times the x plus 1 gets us the 2x to the cube that we need. So we can just write 2x squared right here. And then we would have 2x cubed plus 2x squared. And now we would just cross this out because 2x cubed minus 2x cubed, those just cancel out. And then we have 3x squared minus 2x squared. That just gives us x squared. And these terms right here, they just drop down. So x squared minus 2x minus 3. Okay, now we have to do basically the same process. So we have an x squared term. So let's just write x plus 1. And then times what gives us x squared. Well, we can just do x times x, and then we can distribute the x again. And then we'll have x squared plus x. So that's what we have remaining. So again, just like the 6 times 3, the x plus 1 times x gives us x squared, so we'd have this x. Because our goal is to cancel out all these parts in the inside to hopefully get like the simplest form. So we can just do plus x, and then right here, again we're subtracting x squared plus x. So again, these terms would cancel out, and this would be negative 3x because it's minus 2x minus x, and this minus 3 would just drop down. Now let's do the same thing again. So we need to get negative 3x. So we do x plus 1 times what will give us negative 3x. Well, we know that's negative 3. So that would just be, if we distribute the terms again, negative 3x minus 3. So just subtract 3 right here, and then minus negative 3x minus 3. Well, a minus and minus, that becomes plus, so negative 3x plus 3x, those cancel out, and same thing here, so we're left with 0. So that means our answer for this problem we have up here is 2x squared plus x minus 3. So that's how you do polynomial long division. And I'm going to go over more examples now to hopefully make it more clear. But that's basically the process you have to do. So let's go over to our next example. I'm going to call this example 2. Okay, and this time we have 3x cubed plus 5x squared minus x plus 2, and then divided by x minus 2. Okay, so we just gotta set it up like how we had before. So remember, the x minus 2 goes right here, or the divisor goes right here, and then the dividend, this top part, goes right here, so that's 3x cubed plus 5x squared minus x plus 2. Make sure you give yourself like enough space to do this division, because you'll need it for both the top and like to fit the polynomial. Okay, so again, let's do the same process. So we have x minus 2, so we need to get 3x cubed. So what will give us that? Well, that'll be 3x squared, and that'll just be 3x cubed minus 6x squared cubed. Okay, so we can just write 3x squared over here, and subtract, and 3x cubed minus 6x squared. Okay, those cancel out, and that becomes positive, so this becomes 11x squared. And remember, the terms just drop down. Minus x plus 2. Okay, again, same process. So x minus 2. This can, as you guys can see, can be like a repetitive process. So it can be like kind of tedious, but you guys have to do it. So, and then we're trying to get 11x squared. So we would have 11x right here. So that would be 11x squared minus 22x. There's another form of division that's, I guess, that would be simpler, and I can create a video on that if you guys want. And yeah, this is like the fundamental though. You guys have to know from like most classes. So we add 11x right here, and then we're subtracting 11x squared minus 22x. So those cancel out, and that becomes positive. So this becomes 21x plus 2. Alright, we have that right here. And now we have to do again. We're almost done. So x minus 2. And then times what? You guys see 21x. So that'll just be 21. So subtract here. 21x minus 42. And that cancels out this term. And this becomes 44. So when we do this, like last one, x minus 2 times what gives us 44. Well, it won't work because if we put like 44 or something, then we'll have 44x. We still have the remaining x term, so it wouldn't make sense for us to do that. So this is our remainder basically. So how we would write this as our final answer? Oh, I forgot to add the plus 21 right here. Don't forget like that. But how we'd write this is basically it'd be 3x squared plus 11x plus 21 plus, and then what we would do is have the remainder on the top, 44, and then divided by the x minus 2, whatever we have in the denominator term. So that would be our final answer. That is how you guys have to write this. Okay, let's go into our third example now. Again, if you guys need more practice, there'll be a question worksheet in the comments. So yeah, I'll just label this example 3. Example 3. Okay, so this one is 2x to the 4th minus 3x squared plus 4 divided by x squared plus 1. Okay, what we have here is see in the numerator we have 2x to the 4th, and then we jump to x squared. We're missing the x cubed term, and right here we're also missing the x term. So when we set up our division, I'll show you this. X squared plus 1 divided by 2x to the 4th. We have to include like zeros, because zeros, they show that it's like it shows like it says 0. It won't have any impact to the question, but it's like we have to include the x cubed term to make like the division happen smoother. So we'll just have plus 0x cubed, because we have 0 terms of x cubed, minus 3x squared plus 0x plus 4. So that's how we rewrite it. And then yeah, just do the same process. So I want to do this one a bit more faster. If you guys want to go over it, just pause the video and try to solve it yourself as well. I recommend doing that for all the problems here. So this would be 2x squared, and then this 2x multiplies right here. That becomes 2x to the 4th, and then right here, when we do this multiplication, we also have this 2x squared term left right here. So we have to add right here this 2x squared. So that would cancel out this term right here. And then we can leave this 0x cubed because that's just a term. We just have to use it as like kind of like a filler right here. So this would leave us with a 5x squared plus 0x plus 4. And then now we just have to do minus 5 because we have an x squared term right here. So 5 times this x squared plus 1 will give us that 5x squared. So minus 5x squared and then minus 5. And this would cancel out right here. And this would be 9. So we can't go any further than that. So our answer for this problem would be 2x squared minus 5 plus 9 divided by x squared plus 1. And that's our final answer. Okay, so that's the end of the video. If you guys need more help, there'll be a practice worksheet in the comments. And yeah, thank you so much.